Hey guys, welcome to Math Genius channel once again. Today we'll be looking at the multiplication of matrices. Multiplication matrices. Two given matrices are said to be conformable for multiplication. That means that we can only multiply two given matrices if and only if the number of columns in the first matrix is equal to the number of rows in second matrix. If this is not satisfied, we cannot multiply two matrices. That's to say that the number of columns in the first matrix must be equal to the number of rows in the second matrix before you can multiply two of them. If A is equals to Aij okay, that is A11, A12, A13, A21, A22, A23, and B is equals to BI, B1, B2, B3. A dot B, that means multiplying first matrix and second matrix. That is A11, A12, A13, A21, A22, A23, dot B1, B2, B3. You see, for this to be possible, the number of columns in the first matrix must be equal to the number of rows in second matrix. This is the first matrix. How many columns? 1, 2, 3. 3 columns. This is the second matrix. How many rows? 1, 2, 3. 3 rows. So the number of columns is 3. Number of rows is 3 that side. We can multiply this. Now we look at how we carry out multiplication in matrix. It's very technical. Please pay attention. In multiplying matrices, what we simply do is this. We use the first row to multiply the first column. If you have more than 2 columns or 3 columns here, first row multiply column, multiply and multiply. When you are done using the first row, you come back and use the second row, and so on. That's so that if I bring out this first row, the first row here is A11, A12, A13. I'll use it to multiply the first column. First column here is B1, B2, B3. So when I bring the first row out, if I superimpose it on this, A11 will be on B1, A12 will be on B2, A13 will be on B3. So the first row will multiply first column here. I'll have A11 will multiply B11. I'll have A11 dot B1. I'll add A12 multiply B2, A12 dot B2. I'll add it. B13 multiply B3, A13 dot B3. See that? First row will multiply first column, such that A11 will be on B1, A12 will be on B2, A13 will be on B3. We have this. We are done with the first row. We go to second row. We bring second row out, superimpose it again on this. A21 will be on B1, A22 will be on B2, A23 will be on B3, such that you have A21 on B1, you add A22 on B2, you add A23 on B3. You see? And the value you get here is your answer. Now we have looked at how this is applied. We are going to use numbers, not elements again, so that you get it clearly. Let's go to example 1 on this multiplication. Example 1. If A is equals to 1, 5, 2, 7, 3, 4, and B is equals to 8, 4, 3, 1, 2, 5, 8, 6. Look at this. Find A dot B. This is multiplication. Multiply matrix A and matrix B. Now pay attention. Solution. A dot B means matrix A 1, 5, 2, 7, 3, 4 dot 8, 4, 3, 1, 2, 5, 8, 6. Remember what we discussed before? You see, these two matrices can be multiplied because the number of columns in the first matrix is 1, 2, equals number of rows in the second matrix, that is 1, 2. So we can multiply this. And while multiplying, I said the first row, that is this. first row 1 and 5. You will use first row to multiply first column. That is this. Carry the first row, superimpose it on the first column and multiply. That is 1 and 5, keep it on 8 and 2. So 1 on 8, 5 on 2. We have 1 multiplied by 8. You have 8. You add. 5 multiplied by 2. That is 10. Is that clear? First row multiply first column. 1 times 8 is 8. 5 times 2 is 10. Then carry it again. First row on top of the second column again. 1 by 4 will give you 4 plus 5 by 5, 25. Again, carry it and keep it on third one. 1 by 3 will give you 3. 5 by 8 will give you 40. 40. Let me keep this away. You can see it very well. Equals to, let me go again. 1 by 8 will give you 8 plus 5 by 2 will give you 10. 1 by 4 will give you 4 plus 5 by 5, 25. Carry it and keep it here again. 1 by 3 will give you 3. 5 by 8 will give you 40. Carry it and keep it here again. 1 by 1 will give you 1. 5 by 6 will give you 30. You are not done yet. Now you are done with the first row. Now come to second row and repeat the same process again. Second row is 2 and 7. Carry 2 and 7 and keep it here again. Then 2 will be on 8, 7 will be on 2, and so on. 2 by 8 will give us 16. Then 7 by 2 will give us 14. Carry and keep again. 2 by 4 will give us 8. 7 by 5 will give us 35. Carry and keep it again. 2 by 3 will give us 6. 7 by 8 will give us 14, 28, 54. Carry and keep again. 2 by 1 will give us 2. 7 by 6 will give us 42. You're not done yet. The last row, multiply the columns this side. 3 and 4, keep it on this 8 and 2. You have 3 on 8, 4 on 2. So 3 by 8, 24, plus 4 by 2 is 8. 3 by 4 is 12. 4 by 5 is 20. 3 by 3 is 9. 4 by 8 is 32. 3 by 1 is 3. 4 by 6 is 24. Now you have got this out. Your final answer becomes 8 plus 10 is 18. 4 plus 25 is 29. 3 plus 40 is 43. 1 plus 30 is 31. 16 plus 14 will give us 30. 8 plus 35 give us 43. 6 plus 54 will give us 60. 2 plus 42 give us 44. 24 plus 8 will give us 34. 12 plus 20 give us 32. 9 plus 32 will give us 41. And 3 plus 24 will give us 27. And that is your final answer. See? Multiplication in matrix is tedious, but if you follow it sequentially without jumping step, you will surely get the correct answer. We'll take another example to explain this multiplication so that it will be well understood. Example 2. If matrix A is equals to 2, 4, 1, 3, find A squared. Look at this. A matrix can be squared. It's possible to square a matrix if it's a square matrix. But if it is not a square matrix, it's not possible to square a matrix. A square matrix is a matrix that has the same number of rows and columns. As you can see, this is 1, 2. 2 rows, 1, 2. 2 columns. So this is a 2 by 2 order of matrix. 2 by 2 is a square matrix. 3 by 3 square matrix. 4 by 4 square matrix. Let's see how we can solve this problem. A square means A dot A. It means 2, 4, 1, 3 dot 2, 4, 1, 3. You see, first matrix has 2 columns, 1, 2. Second has 2 rows, 1, 2. So we can multiply them. The process remains the same and very simple. The first row is 2 and 4. Bring it out. Superimpose it on the first column. That is this first row on this first column. So 2 on 2, 4 on 1. 2 times 2 is 4 plus 4 times 1 is 4. You go again, still carry it and keep it on the second column. 2 on 4, 4 on 3. 2 times 4 is 8 4 times 3 is 12. You're done with the first row. Go to second row, 1 and 3. Bring it out and keep it on here. 1 on 2, 3 on 1. 1 times 2, 2. 3 times 1, 3. Carry it, keep it here again. 1 on 4, 3 on 3. 1 times 4 is 4. And 3 times 3 is 9. Final answer. 4 plus 4 is 8. 8 plus 12 is 20. 2 plus 3 is 5. 4 plus 9 is 13. And this is your answer. Very simple. We look at third example. Third example. Example 3. If A is equals to 2, 1, 4, 3 minus 1, 0. And B is equals to 'Find A multiplied by B. Let's solve this. Solution: A multiplied by B. Look at it. Matrix A has how many columns? 1, 2, 3. Matrix B has how many rows? 1, 2, 3. That means they are conformable for multiplication, so we multiply. We say that 2, 1, 4, 3 minus 1, 0. Should multiply 1 minus 1, 2, 2, 3, 1. What I've been doing, carry the first row and multiply the first column. See the first row, 2, 1, 4, multiply it 1, 2, 3. So 2 will be on 1, 1 on 2, 4 on 3. We now say 2 multiplied by 1, we have 2. 1 multiplied by 2, plus we have 2. 4 multiplied by 3, we have 12. That one is done. Carry it again and go to second column. 2 multiplied by minus 1, minus 2. 1 multiplied by 2, 2. 4 multiplied by 1, 4. We are done with that. Go to second row on the first column. 3 and 1, 3. Minus 1 and 2, minus 2. 0 times 3, 0. Carry the second column again, second row again on the second column. 3 and minus 1, minus 3. minus 1 and 2, minus 2, 0 and 1, 0. So your final answer becomes equals to 2 plus 2 plus 12 will give us 16. Minus 2 plus 2 is 0, plus 4 will give us 4. Minus 3 minus 2 will give us 1. Minus 3 minus 2 is minus 5, plus 0, minus 5. And this is your answer. That's very simple. If you follow this method, there is no question that involves multiplication in matrix you cannot solve. So, we look at last example. Last example on this. Example 4. Given that A is 1, 2, 0, 1, 4, 2, and B is equals to 1, 0, 2, 2 minus 1, 1. Find A dot 2B. Look at this. A dot 2B. We have A here. Solution. We have A here. We have B. We're looking for A dot 2B. We don't have 2B. First of all, we'll get 2B. 2B means 2 multiplied by B. What is B? 1, 0, 2. 2 minus 1, 1. What will you get? When a number is outside the rectangular array, the number will multiply everything inside the rectangular array independently, meaning that the number outside will multiply each of these number or elements in the rectangular array. That is 2 times 1, 2, 2 times 0, 0, 2 times 2, 4, 2 times 4, 2 times 2, 4, 2 times minus 1, minus 2, 2 times 2, 2. So this is your 2B. In that case, we now solve A dot 2B means what is A? 1, 2, 0, 1, 4, 2. Dot. What is 2B? 2, 0, 4. 4 minus 2, 2. We now start to solve. First row is 1, 2. Multiply first column. First row, multiply first column. First row, second column. First row, third column, and so on. So we now have 1 on 2, 2 on 4. So 1 times 2 will give you 2. 2 times 2 give you 4, will give you 8. Plus 8. First row on second column, 1 times 0, 0. 2 times minus 2, minus 4. 1 times 4 is 4. 2 times 2 is 4. You're done with that first row. Now go to second row and go through again. Second row is 0 and 1. Multiply here, here, here. 0 on 2, 0. 1 on 4, 4. 0 on 0, 0. 1 on minus 2, minus 2. 0 on 4, 0. 1 on 2, 2. Now done with that, come to the third row. Use it and multiply each of the columns. 4 and 2, 8. 2 and 4, 8. 4 and 0, 0. 2 and minus 2, minus 2. 2 and minus 2, minus 4. 4 on 0, 0. 2 and minus 2, minus 4. 4 on 4, 16. 2 on 2, 4. So final answer becomes 2 plus 2, 10. 0 minus 4, minus 4. 4 plus 4, 8. 0 plus 4, 4. 0 minus 2, minus 2. 0 plus 2, 2. 8 plus 8, 16. 0 minus 4, minus 4. 16 plus 4, 20. And that is the answer. As you can see, it's not too difficult. We have come to the end of today's class. Thank you for staying with me to the end. Don't forget to come back to the channel, and don't forget also to subscribe and click on the notification bell so that when I drop another video, you'll be the first to get it. Thank you. Bye.